exponential functions that we have. It depends on the scenario that we are getting. Okay? Remember, do you guys remember what an exponential function looks like in a graph?
Yeah.
Parabola is a quadratic.
No.
So an exponential function, how would it look like?
Increase and decrease?
No? What does exponential mean?
It has an exponent?
The variable is your exponent, right? So an exponential function is when you have, let's say the variable is the exponent, so 2 to the power of x. That's an exponential function, okay? Or when you have y equals 100, 0.5 to the power of x, right? You see that your variable, right, is in the exponent. Okay, that's what an exponential function is. Okay? Now, an exponential function is going to have the property of where you start flat and then you either grow exponentially, okay? So at first you're like growing slowly, but then it's a huge increase after that. So let's look at an example here. Let's say if I want to double a number, okay? So let's say I start with what? What's double of 2? What's double of 2?
4.
What's double of 4? Double of 8. Double 16. Double 32. So you see, at first it was 1, 2, 4. Now it's 32, 64. What's double of 64? 128. Double of 128. 256. So you see how at first it was like 1 unit or 2 units or 3 units, but now I'm doubling by 100, right? I'm increasing by 100 units. And then if I keep going, it's going to be by 500, by 1,000, and by 2,000, right? It keeps growing, right? So this is what we call an exponential function, okay? Or it could be, this is an exponential growth, right? Where it's growing fast. But it could also be an exponential decay, right? Where it's like decreasing fast and then it slows down, right? So let's say if I have a piece of paper and I want to break that piece of paper, right? Or let's say if I have a count of bacteria and then I gave them antibiotics, right? And then the amount of, I don't know, antibiotics kill bacteria. I don't know. Yeah, that's the virus that doesn't. Anyway, so they will decrease fast first, right? If you're decreasing by half and you have like 1,000, right? 1,000, then 500, then 250, then 125, and then it's gonna start decreasing slowly, right? But at the beginning, the half of 1,000 is 500, so it's a huge decrease. Are we okay with how an exponential function looks like? Now, we have 4 different ways. Well, we're going to look at 4 different ways where how can we create or how can we find an exponential function, or what does it mean? What do these numbers in an exponential function mean? Okay? So the first one that we're going to look at is called an exponential growth, and that is used whenever I have a rate. Okay? So this is for growth. When a rate, this is a W.
Then they give you 1 minus I?
Yeah, is given to me.
Like 10 grade, kind of like 10 grade?
That's a 1 plus I. The other one, 1 minus I would be which one? Exponential decay. Okay, so let's look at an example here. Okay, so let's say if I have, if I'm putting money in the bank, okay, I'm putting $500 in the bank right now, and it's gonna grow at a rate of 2%. Okay, so you see that. So the deposit, the initial deposit is $500, and the interest rate is 2%. Okay, Is my money growing or decreasing? Growing, right? So that means it's an exponential growth. All right? So I can use this formula where I can plug in y equals for a, which is my initial value, right? So how much money, what did you start with? So that's the 500. In for I put the rate, but in decimal. So what am I going up by?
In decimal.
What's the percentage I'm going up by? 2%, which is 0.02, right? So I write 1 plus 0.02 to the power of x, where x is the number of year, or it could be the time, or it could be, I don't know, it could be the number of days. I don't know what x, depending on the unit of x. Okay? So the equation is y equals a 1 plus I to the power of x, where you're going to have to plug in values for a, I, and x. It will stay as x unless I say, how much money do you have in the account after 10 years? Right? Then what do you do?
Instead of 50, you're gonna add 10.
That's right. Instead of x, we're going to add 10. Because now I'm telling you how much money will you have in the account after 10 years. I'm specifying the x value. Okay? But for now, this is going to stay like this. Y equals 500 with a base of 1.02 to the power of x. Do you guys understand that part?
Why not plus?
Because 1 plus 0.02, that's 1.02.
So that's one, so the solution, like the formula is a, y
Oh,
equals
we
a.
already did that.
The answer.
This one?
That's 1 plus I.
That's 1 plus
Oh,
I.
okay.
Yeah.
I thought it was a C, sorry.
No, that's an I. I represents the interest
Okay.
rate.
And the 2% became 0.02?
Mhm. Because 2% is 0.02. If you divide 2 by 100, right? So this,
Put the decimal.
you can't put it as 2, right? Otherwise, then your money's tripling. And this is not what's happening. You have to change this to decimal, which is you divide it by 100 and you find it. Because a percentage means it's out of 100. Okay? Now, does this look something like this a bit? The way the format of it? Yes, it does. You have a number multiplied by a base, right? And then to the power of a letter, right? Okay. Now let's look at the second formula that you can use. So we said that this one was for the exponential growth. Okay? So if your money is growing, or if whatever you have, the value of it is growing. Now what happens if it's decay? It will be 1 minus the I. That's right. So it's going to be the same thing where you have a 1 minus the I to the power of x. This I use when I have exponential decay. Decay. Okay, when it's decreasing, and when an interest rate is given to me. So let's look at an example. You bought a car for $20,000. The value of the car is going to depreciate by 5% every year. Okay? So you see the word that I'm using? Depreciate, or decrease in value. So this is where you know it's going to be an exponential decay. Right? So let's write down the question. So you have a car, purchased a car. For $20,000. the value of the car is depreciating by 5% per year. So the question would be, write an equation that represents the situation where x is the number of years. Okay? So how would I write that?
20,000 is the
Y equals
initial goal value.
Yeah. So this is your initial 20,000. So y equals
20,000.
20,000.
1
1 minus
minus
0.05.
plus 1. 1.
No.
1 minus.
Minus 1 mean.
And then to the power of x, the number of years, right? It could be after 5 years you want to know how much your car would be worth. Or it could be after 10 years you want to know what your car is worth. Okay? It's x. Are you guys okay with that? Yeah? And then if I do the simplification for this, y equals 20,000. And then this is going to be 0.95 to the power of x. Okay? So this is where my equation, what my equation would look like. Okay. Now, eyes on me for a second, please. So if I'm looking at this and this, compare the base of my exponential function. Can you compare the base for me? Can you tell me what's the difference in the base?
1.0.
One is going to be more than 1. One is going to be probably less than 1.
So this one is greater than 1, the 1.02, but this one is between 0 and 1. Anytime that you have a base that is greater than 1, then we call that exponential growth. This is how you're going to know it's exponential growth, because your base is greater than 1. Okay? So if your base is greater than 1, then we know it's an exponential growth. If your base is, we call that between 0 and 1, then it's an exponential decay. Are you guys okay with that? So far, yes. Basically, this is what we start learning in grade 11, right? Now, so far we've covered 2. Exponential growth, exponential decay, when a rate is given to me. So when that question tells me 2%, 3%, 5%, something that is a rate, that's percentage. Now, sometimes the question is going to say, let's say you have a bacteria in a petri dish, and the bacteria count is doubling every 2 hours. Right? Doubling every 2 hours. If I start with 100 and I double, the first 2 hours, I'm going to have from 100, it's going to be 200. Then it's going to be 400. Then it's going to be 800. Then it's going to be 1,600. And that's after like 2 hours each. 2 hours period, right? So I know that this is an exponential growth. But this is called a special case because I'm using the word doubling. Okay? So in this case, what would be my base? What would be my base? What would be my base? 2. Because it's doubling. Right? 100, then 200. So you multiply the 100 by 2. You multiply the 200 by 2. You multiply the 400 by 2. So you're multiplying by 2 every time. So your base is 2. Now, the difference here, A is still your initial value, so whatever you're starting with. Multiply by 2. Now, this is where the difference is. It's not only to the power of x, it's actually to the power of t, which can be x if you want, but divided by d, which is your doubling time. Okay? So that example that I just gave you, that your bacteria doubles every 2 hours, that would be your d value. Okay? So let's look at an example. So you have 100 bacteria doubling every 2 hours. Okay? So, huh?
Would T be time?
T would be time without me changing it. T is going to be your unknown. T is going to be there, and then when I say how many bacteria do you have after a day, then you know that you're going to replace T with 24 because you're looking at that. Okay? What's my A value?
100.
And then my base is not going to change. It's going to be 2 because it's double. Right? T is going to be T. It's going to be your unknown. That's an exponential function. Your exponent has to be unknown. And then what am I going to divide it with? 2. Because that's your 2 hours. This is your doubling time. Think about it this way. If it doubles every 2 hours, how many doubling periods do you have in 24 hours? 12. Right? Because you take the 24 and you divide it by 2, that gives you 12. Right?
So it's going to be 2 to the power of 12?
It's going to be 2 to the power of 12 after you do your math.
Okay.
Yes. Okay? But what you plug in for T, you plug in 24. 24 divided by 2, that's 2. And that's why we divide by that. Is because it's only doubling 12 times in the full day period. Make sense? Okay. So this is the case of doubling. Then we have the case of half-life. So a lot of time when we are doing, let's say, studies of radioactive material or of a certain chemical, we see that the chemical is being reduced, or its half-life is 1,000 years. Okay? So when we use that word half-life, then my equation changes to the half. So what would be my base in that case? What would be my case? 0.5, my base. So it's going to be y equals A, because it's half-life, so basically I'm taking something and I'm cutting it in half. Right? So it's going to be 1/2 or 0.5. And then same thing, it's T over H. We use the letter H just to represent half-life time. Okay? Same, A is my initial, T stays as T. It's how much time would you have? Yep.
So is it always given the half-life time or the doubling time?
Yes.
Okay.
Unless they want you to find it, but they will give you the other stuff then. Then they would give you the Y, they would give you the T, they would give you the A, and they ask you to find the H, which is rarely that happens. Okay? So let's say if I know, let's say I started with a material 10 years ago, right? I had 100 grams of something, right? And then after 10 years, right? I know right now I have, let's say, 25 grams left. What did I start with, 100 or 10? So I started with 100, and now I have 25 after 10 years. What is the half-life time of this material, right? Then I can plug in 25 here. I know that my initial is 100, right? I know that I've used 10 years of the time, then I can look for H. Okay? And a lot of time in real life situation, we don't know what the half-life of a certain, so scientists, they don't know what the half-life, and that's what they're looking 90% of the time, right? Okay, so in this case, are you guys okay with this, or do you want me to give you an example?
One example.
An example? Okay, so a radioactive material has a half-life of, let's say, 1,000 years. You have 250 gram sample. Find an equation to model the situation. So the question is find an equation to model the situation. This tells me half-life. That means I know it's going to be the half, right? So that's going to be y equals A. What's my initial value? 1. What's my initial value?
1,000.
What am I starting with?
Oh, 250.
250.
1,000 is the half-life.
That's right. 0.5 because I know it's half-life, and then T over 1,000.